Welcome back to the series on trigonometry, and this is the third episode on trigonometric identities. Earlier, we have seen sine square a plus cos square a equal to 1, and then tan square a plus 1 equal to secant square a. Now comes the third identity in the series, cot square a plus 1 equal to cosecant square a. To reiterate, how do we master this concept? What does it take to solve any type of question that is related to this concept? We will look at that. So, again, I had divided the understanding of this concept into 3 levels of mastery, right? Let us look at one level at a time. What does level 1 mean? Remembering that cot square a plus 1 is cosecant square a. Just being familiar with it. But is this enough? Might not be. So we need to upgrade to the next level where we say if I take 1 to the other side, I'm going to get cot square a is equal to cosecant square a minus 1. That means wherever I see cot square a, you should evaluate, will writing it as cosecant square a minus 1 help proceed in the problem? Or wherever you see cosecant square a minus 1 in the problem, you should get an idea that it can be replaced with cot square a. Right? The other thing is moving cot square a to the other side. In the sense, cosecant square a minus cot square a equal to 1. If in a problem you see there is cosecant square a minus cot square a, you should realize that that is equal to 1. Correct? Now, again, is this sufficient? Might not be. Maybe we have to go to level 3, which is that ultimate level of mastery. What does that mean? Look at equation number 1. On the right hand side, you can see this looks like in the format a square minus b square. Right? So that is equal to a minus b into a plus b. So you should get an idea that this can be rewritten as cosecant a minus 1 into cosecant a plus 1 is equal to cot square a. Similarly, equation number 2, if you look at it, you should get an idea, again a square minus b square format. You get an idea that cosecant a minus cot a into cosecant a plus cot a is equal to 1. So if any of these questions you come across any one of these, cosecant a minus 1 or cosecant a plus 1 or maybe cosecant a minus cot a or cosecant a plus cot a, it should ring a bell to you that you have seen this somewhere and you should be able to evaluate, can I use this identity in that particular question? That idea you should get. That is level 3 of mastery. Okay. To drive through my point, let us solve few questions and hope that gives you some clarity. The first question, again, I've seen many students without even evaluating anything directly jumping into saying that I'm going to convert everything into sine and cos. You might get the solution there, but might not be the most efficient way of solving that question. Here you need not convert it to sine and cos. If you carefully look at it, 1 minus cot square theta is nothing but, using that identity directly, that is nothing but cosecant square theta. Right? And what are the other two terms? 1 minus cos theta into 1 plus cos theta is a minus b into a plus b, which is 1 minus cos square theta. And what is 1 minus cos square theta? We have seen in the first episode, that is nothing but sine square theta. So this becomes cosecant square theta into sine square theta. Cosecant square theta is nothing but 1 by sine square theta and into sine square theta. This eventually becoming equal to 1. Looks very lengthy, but when you simplify it, the value becomes equal to 1. You need not convert it cot square into sine and cos. Use the identity, the third identity. Now let us look at the second question. Again, I have seen many students considering converting everything to sine and cos as their plan A. I strongly recommend keep that as plan B or plan C. Let that not be plan A. That should not be your first go-to strategy, right? If you look at left-hand side, I've seen this somewhere. Where did I see this? Cosecant A minus cot A into cosecant A plus cot A is equal to cosecant square A minus cot square A that is equal to 1. I have seen this here. Can I use it here? Let me multiply numerator denominator by cosecant A minus cot A. I don't know yet if this is the right approach, but no harm in trying. Trigonometry is all about experimentation. No harm in trying, so let me do that. So cosecant A plus cot A into cosecant A minus cot A by cosecant A, minus cot A, which becomes, numerator becomes cosecant square A minus cot square A square minus B square identity, and denominator is cosecant A minus cot A. That is equal to, numerator becomes 1, that's what we have seen, and denominator remains as cosecant A minus cot A. Now how do I proceed? If I look at the RHS, it is in sine and cos. So now you can go ahead and convert everything that you have into sine and cos. So when you do that and simplify, it boils down to sine A by 1 minus cos A, which is equal to RHS. Right? So this is level 3 of understanding, where you have seen this somewhere. And your first thought is, can I somehow bring the whole thing to that identity that I know? Again, I'm saying there are multiple approaches to a trigonometric identity based question. This is one of those approaches. But you need to evaluate which is the best path to take. Right? One more. A scary looking one. You might be tempted to go ahead with the multiplication. But before you get into the multiplication, observe what is given. If you look at carefully the question on the LHS, this and this you have seen somewhere. Again, where is it? Cosecant square A minus cot square A equal to 1. Maybe you can use that. Before going into direct multiplication, organize your steps. I'm going to call this, let's say, x. I'm going to call cosecant A plus cot A as x. Just assigning a variable to make my multiplication easier. And cosecant A minus cot A as y. So what does the LHS become? X minus 1 into y plus 1. Now if I multiply this, it will become xy plus x minus y minus 1. Now look at xy. What is xy? Cosecant A plus cot A into cosecant A minus cot A, which is nothing but a plus b to a minus b, a square minus b square, cosecant square A minus cot square A, which is equal to 1. So this whole thing will become equal to 1. Then I'll get plus x. What is x? Cosecant A plus cot A. What is y? Minus, be careful with the bracket and the minus sign, minus 1. 1 minus 1 will be 0. So that will go. And what remains is cosecant A plus cot A minus cosecant A plus cot A. Not minus cot A, plus cot A, because minus into minus plus distributive property. Careful with the minus signs. And once I simplify this, cosecant A will get cancelled. You will get 2 cot A. That is equal to RHS. Simple. So, rather than converting everything into sine and cos or directly multiplying everything, just take a 10-second pause and organize your thoughts. Have you seen this somewhere? Can I use that? Can I apply some identity here? That should be your approach. I hope this helped to give you some clarity on how to approach questions based on trigonometric identities. Thank you.